Hey, what is up guys? Welcome to another video. In this video I'll be going through practice set 7 paper 3H. This is the higher specification. This should take you about an hour and 30 minutes to complete, and this is also a calculator exam. Check out papers 1 and 2. They're also on my channel if you haven't seen those already, and I'll post the paper and the mark scheme in the description if you're after those as well. So without further ado, let's get straight into the questions. Question 1 says the diagram shows the position of a lighthouse L and a harbour H. The scale of the diagram is 1 centimetre represents 5 kilometres. Work out the real distance between L and H. So because they've given us a scale here, we need to measure the length of that line with a ruler. So take your ruler and measure the length from L to H, and I get 8.5 centimetres. Okay, so 8.5 centimetres is the length of the diagram, and we need to multiply that by 5 to get the real distance. So 8.5 times 5, that's 42.5. So the real distance between L and H will be 42.5 kilometres. Part B says measure the bearing of H from L. So for this question we need a protractor, and you can take your protractor, and we need the bearing of H from L. So we're going this way. So we need that angle from north around to this line towards H. So we place the protractor on, put the center on L, place the 0 on north, and I can't exactly get it lined up just due to this program that I'm using, but if I had that exactly lined up on the north line, that would say, well, read around from 0 on the outside numbers. So if I'm looking at the outside numbers here, I get 110 degrees. So the bearing of H from L is 110 degrees. And then part C says a boat B is 20 kilometers from H on a bearing of 40 degrees. On the diagram, mark the position of boat B with a cross, label it B. Okay, so remember we need to measure bearings clockwise. So we're measuring from H, so we need to take our protractor first, and again put the center on H and 0 on north, and then read around on the outside numbers, around clockwise around to 40, and then make a dot on 40. Then we remove our protractor, and we need to take our ruler, and it says the boat B is 20 kilometers from H, so we need to measure a line of 4 centimeters because our scale is 5 kilometers for every 1 centimeter. So if the distance is 20 kilometers, that will be 4 centimeters on our scale. And so we need to take our ruler, put the 0 on H, line it up with the dot we've made at 40 degrees, and then make another dot at 4 centimeters. Okay, so that's going to be where B is on our diagram. And we need to mark it with a cross and label it B. And that's question 1 done. It's very important you remember your tools in the exam. So without a ruler and a protractor, you would have missed these 4 marks for this question. Question 2 says a mixture of sugar and salt is in the ratio 3:2. The weight of the mixture is 150 grams. And part A says calculate the weight of sugar and the weight of salt in the mixture. Okay, so if we have a ratio of 3:2, that means we have 5 parts. And altogether, those 5 parts equal 150 grams. So then we could work out what 1 part is worth in this ratio. So if we divide both of these by 5, 1 part will equal 30 grams. And so if I have 3 parts, 3 times 30, that will be 90 grams. And 2 times 30, that would be 60 grams of salt. So we have 90 grams of sugar and 60 grams of salt. Part B says 30 grams of sugar and 10 grams of salt are added to the mixture. Calculate the ratio of sugar to salt in the new mixture. Okay, so let's work out how much sugar we have. So we had 90 and we added 30 grams, so now we have 120 grams of sugar. And we had 60 grams of salt, and we've added 10 grams of salt, so now we have 70 grams of salt. And so the ratio of sugar to salt, well, that will be 120 to 70. And we can simplify that a little bit. If we divide both by 10, we'll get 12 to 7. We can't simplify that anymore, so you can give 12 to 7 as your answer. Now it doesn't say give it in the form n to 1, so we can leave it as 12 to 7. If it did say we needed it in the form n to 1, then you'd have to convert that into a ratio where 1 is on the right and we have to work out what would be on the left hand side. But it doesn't say that, so 12 to 7 is perfectly fine for your answer there. Question 3 says a equals 2 squared times 3 times 5 squared, b equals 2 cubed times 5. Part A says find the highest common factor of a and b. So when you're given numbers in prime factor form, to work out the highest common factor, you need to take the prime factors that are common to both numbers. Okay, so in other words, if I have a 2 squared here, I have a 2 cubed in b, but if I'm looking for the common prime numbers, there's only a 2 squared in both. So I've got 2 squared, that's common to both numbers. I have a 3 in a, but I don't have a 3 in b, so I can't include 3. And then I have a 5 squared in a and only a 5 in b. So one lot of 5 is common to both. And then we multiply those common prime factors together to get the highest common factor. So 2 squared times 5, that's going to be 20. So your answer there is 20. And then part B says find the lowest common multiple of a and b. So for the lowest common multiple, you want to take the prime factors of both without repeating anything. So one way to do this is draw a Venn diagram, but you can do it without drawing a Venn diagram. You can just look at the prime factors and say, well, I've got a 2 cubed here, and then a 3, and then a 5 squared. So another way of explaining this is you're taking the powers of 2 that has the highest power and using that in your operation. So in A we have a 2 squared, but in B we have a 2 cubed, so we take the 2 cubed rather than the 2 squared. In A we have a 3, and we don't have any 3's in B, so we write down 1 3 for the lowest common multiple. And then for A we have a 5 squared and only 1 5 in B, so we take the 5 squared in our operation. So you take every number in A and B and you take the highest power of that number that exists. And you multiply those together and you get the lowest common multiple, which is going to be 8 times 3 times 25. And well, this is a calculator paper, so just whack that straight into a calculator and you get 600 for the lowest common multiple of A and B. Question 4 says, here are the ages in years of 15 women at West Ribble Tennis Club. Part A says, on the grid, draw a box plot for this information. Okay, so for a box plot, we need the median, the lower quartile, the upper quartile, the minimum, and the maximum. Okay, so for the median, we want the middle value, and that's done by taking the number of values we have, so 15, add 1, and divide by 2. So the middle value here will be 16 divided by 2, which will be the 8th value. So we count along, 2, 4, 6, 8, and 28 is our 8th value. So the median is 28. So we can mark that on our box plot here. So the scale here is every line is 1 unit. So that's 25, 26, 27, 28. So that's going to be our median. So draw a line for the median. The lower quartile is, we kind of do a similar operation. We take the number of values, add 1, but now we divide by 4 because we want the first quarter of the values. So we divide by 4 rather than 2 to get a quarter. And for that, we'll get 16 divided by 4, that will be the 4th value. So we want to go along to the 4th number in this list. that would be 20. So our lower quartile is at 20. So draw a line for the lower quartile. The upper quartile, for this we want to do similar to the lower quartile, 15 plus 1 divided by 4, but this time we multiply it by 3 to get the value at 3/4 of the list. So 16 divided by 4 is 4 times 3, that's the 12th value. So count along the list. This was 8, 9, 10, 11, 12. So the 12th value here is 42. So 42 will be our upper quartile. So mark a line at 42. And so we have our median, lower quartile, and upper quartile. Minimum and maximum are easy. You just need to read off the lowest number and the highest number. So the minimum here is 16. So mark a line at 16. I like to draw the minimum and maximum as a smaller line than the other ones, but you don't really have to. You can do it the same width. And the maximum is 50. So draw another line at 50. And then we just have to draw the box. So the box goes around the median and the quartiles. And then we have to draw the whiskers, which go from the end of the box to the minimum and maximum. Okay, so there you have your box plot representing that information. Part B says the box plot below shows the distribution of the ages of the men at West Ribble Tennis Club. So it gives you a box plot here, and then it says use the box plots to compare the distributions of the ages of these women and the distribution of the ages of these men. Okay, so we just need to read off some values from this box plot. So we can say that the median is the line in the middle of the box, and that is 35 is here, so that must be 36. So the median age of the men is 36. The lower quartile, that will be at 26. The upper quartile will be at 40. The minimum, that's 20, and the maximum is 46. Okay, so we have the values from that box plot. Now let's compare them to the women. Okay, so the women, the median was 28. So compared to the men, that's quite a bit lower. So that's one thing we could say. We could say median. So we could say the median age of men is higher than the women's median age. And we could also comment on the spread, or the interquartile range. So the interquartile range for the men is the difference between the lower quartile and the upper quartile. So that's 14. So the difference between these two, 14. And the interquartile range for the women, that was 20 to 42. So that was 22. So we could say that the interquartile range, of men is lower than the women's interquartile range. And it's a 2-mark question, so just make 2 observations. You could also talk about the difference between the minimum and the maximum. So the range of ages of the women is larger than for the men. So for the men it was from 20 to 46, for the women it was 16 to 50. So the range of the women is larger. Question 5 gives us a grid with a trapezium, and it says enlarge shape S with scale factor 1/2 and center 1, 3. Okay, so let's first find the center, that's at 1, 3. And we need a scale factor of 1/2. So starting at this point, to get to one of the vertices of shape S, we need to go up 2 and across 4. If we have a scale factor of 1/2, we need to half those distances. So we can go up 1 and across 2. So that point will enlarge to this point here. And then to get to this point, we need to go up 2 and across 6. So the enlarged point of this point here will be up 1 and across 3. And now I can just shrink this shape down by 1/2. So this side here will be 1, a length of 1. This side here will be, well, if this side is 4, this length on the enlarged shape will be 2. So I have my 4 points of this shape. I can go ahead and draw the outline in like that. And do we need to label it anything? Nope. So we can just leave it as that, maybe shade it in. Okay, so your enlargement should look like that. Question 6 says, given that for all values of x, 6x cubed plus 7x squared minus 56x plus 48 equals 2x squared plus kx minus 12 multiplied by 3x minus 4, where k is a constant, find the value of k. Okay, so what this is saying is to expand these brackets and then match up the coefficients with this expression to find the value of k. So firstly, let's take these brackets here. So we've got 2x squared plus kx minus 12 multiplied by 3x minus 4. And so let's expand these out. So we can take the terms in the first brackets, multiply them all by the first term in the second brackets. So 2x squared times 3x, that's 6x cubed. And then kx times 3x, that's going to be 3kx squared. And then minus 12 times 3x, that's going to be minus 36x. And then we take all of these terms and multiply them by the second term in the second brackets. So 2x squared times minus 4 will be minus 8x squared. And then kx times minus 4, that's going to be minus 4kx. And then minus 12 times minus 4, that's going to be plus 48. Okay, now we can go ahead and simplify this by combining like terms. So there's no like terms with the 6x cubed, so we can just leave that as it is. And then 3kx squared and 8x squared, they're kind of like terms, but we can't actually subtract them because we have a k here and an 8 and no k in this one. So I'm just going to write them next to each other for now, and we'll deal with them in a little bit. So 3kx squared minus 8x squared. And then this 36x and this 4kx, they're kind of like terms as well, but again we can't subtract them because this one has a k in it, so I'll just write them next to each other. So this is 36x minus 4kx, and then all we've got left there at the end is a plus 48. Okay, so I'm going to do some factorizing here. So I've still got that 6x cubed at the start, just like in the answer up here. But now I want to factorize the x squared out of this of these two terms. So what I'll end up with here is plus x squared bracket 3k minus 8. And then also I want to factorize these two terms here, and I'll factorize a minus x out. So I end up with minus x bracket 36 plus 4k. And then still that plus 48 in the end. What that allows me to do is to say that 3k minus 8 must equal 7 up here, because we're told that this equals this, and so the coefficients must be equal. So 3k minus 8 must equal 7, because this is the coefficient of x squared, and up here we have 7 as the coefficient of x squared. And we can use this to go ahead and solve for k. So 3k must equal 15, add 8 to both sides. And so k equals 5. And you can check that by substituting it into this one. So 36 plus 4 times 5, that's 36 plus 20, which is 56, which matches up with this coefficient here. So in this problem, k must equal 5. Question 7 gives us a diagram, and it says A, B, C, D are points on a circle. A, B, C, D is a square of side 7 centimeters. Work out the total area of the shaded regions. Give your answer correct to the nearest whole number. Okay, so what we need here for this problem is a radius, because we need the area of this square and the area of the circle. And the way we can find the radius of this circle is to find, well, let's just draw in the radius. So the radius will be here or here. So the center of the circle will actually be also the center of the square. And if I've drawn two radii from the vertexes of the square, they will meet at 90 degrees. So what we have here is a right angle triangle with a hypotenuse of 7. These lengths must be the same because they're both radii of the circle. So of course all radiuses in a circle are the same length. So this allows us to solve for that length there. That will give us the radius. And actually, let's label that r for radius. Okay, so we can use Pythagoras' theorem, which says two legs of a right angled triangle squared add up to the hypotenuse squared. So we can say that r squared plus r squared equals 7 squared. Well, this is two lots of r squared equals 49, which is 7 squared. And so r squared equals 49 on 2. I'm just going to leave it there for now. We don't actually need r by itself, and you'll see why in a second. So to find the shaded region, we need the area of the square and the area of the circle. So the area of the square, well, that's easy. That's just the side length squared. So area of the square is going to be 7 squared, which is 49 centimeters squared. And now we need the area of the circle. So the area of the circle is pi r squared. That's how we find the area of the circle. That's the formula we need. And so here we've got r squared, so we can say the area of the circle is pi times 49 on 2. Okay, and to find the shaded region, we need to take the area of the circle and subtract the area of the square. So the shaded region is going to be 49 on 2 pi minus 49, and so we can put that straight into a calculator. So let's do that as 49 on 2 times pi. Find the pi button somewhere on your calculator. You'll probably have to press shift to get that, and then minus 49. If you put it in like that, it should give you the correct answer, and it gives us 27.969. Rounded off, 27.969, and we need that to the nearest whole number. So the question says give your answer correct to the nearest whole number, so that's going to be 28. So the shaded region equals 28 centimeters squared. This type of question has actually come up in other past papers, so it's useful to know how to find the radius of a square inside a circle. Make sure you're familiar with that method. Question 8 says Danielle invested £2,800 for n years in a savings account. She was paid 2.5% per annum compound interest. The interest is paid into the account at the end of each year. At the end of n years, the amount of money in the savings account is greater than £3,000 for the first time. Work out the value of n. Okay, so we started with, so the principal, or the starting amount, is 2,800. And for these types of questions, I like to summarize the information in my own words. So I start off by writing down the key bits of information. The rate is 2.5%, and we want the amount or the annuity at the end of the period to be greater than 3,000, and we're looking for the time. Okay, so one way we could do this is to use the compound interest formula. The compound interest formula looks like this, where the amount at the end equals the principal, or what you started with, multiplied by 1 plus the rate to the power of the amount of time that you invested in it. So if we substituted all of these values into this formula, we would get, well, let's just say the minimum it could be is 3,000. So let's put 3,000 in, and that will give us the minimum amount of time that we would have to invest it in to get an amount greater than 3,000. So 3,000 will equal 2,800. And then 1 plus r, we need r as a decimal, so that's going to be 0.025. So we substitute that into there and we get 1.025, and we're looking for t. Okay, so we could say if we rearrange this, 1.025 to the power of t will be 3,000 divided by 2,800. Okay, so let's do that in a calculator. So 3,000 divided by 2,800, that gives us 1.07142 blah blah blah. So let's write that down, 1.0714286. Let's round that off. Okay, and so we want some number, we want some power, so that 1.025 to the power of something equals 1.07, etc. So we can use trial and error here. So 1.025, let's say to the power of 2, and let's see what that equals. So that gives us 1.05. That's not quite enough, so now let's put in 1.025 to the power of 3. Let's see what we get. 1.07, and that's greater than 1.071. And remember, we wanted an amount greater than 3,000. So we want this number to be higher than this one, if possible. It can't be lower. So in this case, the minimum time that we could invest to get greater than 3,000 would be 3 years, which was what that power represented. So n here must equal 3 years or more. So it says at the end of n years, the amount of money in the savings account is greater than 3,000 for the first time. So yes, after 3 years, it will be greater than 3,000 for the first time. Question 9 says, n is an integer greater than 1. Prove algebraically that n squared minus 2 minus n minus 2 squared is always an even number. I'm pretty sure a question similar to this came up in the June 2017 GCSE exams. I'm not sure it's exactly the same, but it was definitely pretty similar. So I'll use the same strategy I used there. So first we have to take this expression and simplify it. So we start off with n squared minus 2 minus n minus 2 all squared. And the first thing we have to deal with is these brackets here. So we have to expand those out. So that's the same as n squared minus 2 minus n minus 2 times n minus 2. Okay, and then we can expand them out using FOIL. So this is going to be n squared minus 2 minus n squared minus 4n minus 2n is minus 4n, and then minus 2 times minus 2 is plus 4. Okay, then we have to distribute this negative sign to all of the terms inside these brackets. This is an important step, and sometimes it can be easily overlooked, where you could just remove these brackets without changing the signs of all of these terms, and then you would get the wrong answer. So have to be careful here with this negative sign. So this is n squared minus 2 minus n squared plus 4n. That minus and that minus make a plus, and then this negative and this plus turns that plus 4 into a negative 4. Okay, so now we can go ahead and simplify. So this n squared and this minus n squared cancel out. And then we're left with 4n minus 2 minus 4, that's minus 6. And we can factorize this in the form of 2n minus 3. Okay, so now we need to know a key fact about even numbers. Let's say we had an even number like 10. We can factorize a 2 out of that, so it's 2 times 5. And it turns out you can do this with any even number. You can always factorize a 2 out of an even number. So if you had 50, that's going to be 2 times 25. So if it's an even number, it will be a multiple of 2. So in this case, because we can factorize a 2 out of this expression, that means that whole expression must be some even number. I should mention this is always the case when it's an integer greater than 1. So we can say this expression must represent an even number. So it must be even as it is a multiple of 2. Question 10 says, make E the subject of K equals the square root of 5m plus 2e over 3e. Okay, so the first thing we need to do here is square both sides to get rid of that square root symbol. So we end up with k squared equals 5m plus 2e over 3e. So you can see I've got rid of that square root by squaring both sides. And then we need to get rid of this fraction here, so multiply by 3e, so we get 3e k squared equals 5m plus 2e. You can see it's looking a bit neater now, and we can see that we can get e by itself soon. If we bring this e over to the left-hand side, we'll get 3e k squared minus 2e equals 5m. Okay, now we can factorize an e out of this expression. So e bracket 3k squared minus 2. So I've taken the e out of both of those terms, and then that equals 5m. And now I need to divide this side by these brackets here. So everything inside these brackets bring over to the right hand side and make it a division. So we're going to get E equals 5m over 3k squared minus 2. And that's your final answer there. Question 11 part A says show that the equation x cubed plus 4x equals 1 has the solution between x equals 0 and x equals 1. Alright, so firstly let's get this into the form that we're used to. So we're used to a cubic equaling 0, so let's say that x cubed plus 4x minus 1 equals 0. So now this is the equation we're dealing with, x cubed plus 4x minus 1. So we can say when x equals 0, x cubed plus 4x minus 1. Well, this equals, if x was 0, this would be 0 plus 0 minus 1, this would be minus 1. Okay, and then we can say when x equals 1, this expression becomes x, well, let's write it out again, x cubed plus 4x minus 1. If we substitute 1 in here, that would be 1 plus 4 minus 1, and well, that will be 4. So when x equals 1, this equation equals 4, and when x equals 0, it equals minus 1. So we can say that when the signs change, there must be a solution. So we can say as the signs change, there must be a solution between 0 and 1. If you're confused by that, one way to think of it is the graph of a cubic. Looks like this. It has like a little squiggle in it. And this is a continuous line. All cubics are a continuous line. And so if you get a negative number, that's some point on the line down here. And if it's a positive number, that's some point on the line up here. So because the signs have changed, it must cross the x-axis at some point. So that's what that's saying when we say as the signs change, there must be a solution. It's crossing the x-axis between those 2 points. Part B says show that the equation x cubed plus 4x equals 1 can be arranged to give x equals a quarter minus x cubed over 4. Okay, so let's take this equation and get x by itself. So we would have x cubed plus 4x equals 1. So then we could bring that x cubed over to this side, so therefore 4x equals 1 minus x cubed, and then divide everything by 4, so x equals 1 over 4 minus x cubed on 4, which is what we wanted. There's not much working out there, so that's why it's only 1 mark. And part C says starting with x sub 0 equals 0, use the iteration formula x sub n plus 1 equals 1 over 4 minus x sub n cubed divided by 4 twice to find an estimate for the solution x cubed plus 4x equals 1. Okay, so they've given us an iterative formula here, and we need to substitute 0 into that to get x sub 1, the first step. So we take x sub 0, substitute it in where the xn is, so it's going to go right in here, plug it in there, and we'll get our x sub 1. So we've got a quarter minus 0 on 4. 0 cubed is just 0, and 0 divided by anything is 0. So this is just going to be a quarter. So x1 is a quarter, and then we need to do that again because it says do it twice. So x sub 2, that's going to be a quarter. And this time we have to substitute x1 into this formula, this same formula. So this is going to be a quarter cubed divided by 4. Okay, so now we've got a quarter minus 1 cubed is 1 and 4 cubed is 64. So this top line becomes 1 on 64 divided by 4. And if you divide something by 4, it's the same as multiplying by a quarter. So this is going to be a quarter minus 1 on 64 times a quarter. And because this is a calculator paper, well, we could have really put that straight into a calculator. But let's go ahead and put this into a calculator now. So a quarter, well, let's just say 0.25 minus 1 on 64 times 0.25 equals, and we get 0.24609,375. 0.24609,375. If you wanted, you could also go ahead and simplify this fraction and just get an answer as a fraction. Or let's see, does this give us? Yeah, so you get 63 on 256. So that would be fine as an answer as well, but the decimal is also okay. So they asked us to do it twice, so that's our final answer for part C. Question 12 gives us a graph where on the y-axis we've got cost in dollars and on the x-axis we have distance. And part A says the graph gives information about the cost of taxi journeys of different distances. The cost of a taxi journey consists of a fixed initial charge and a charge per kilometer. Given interpretation of the intercept of the graph on the y-axis. So here's the y-axis and that's the intercept there. So the distance there is 0 kilometers. So that's the cost of going 0 kilometers on your taxi journey. Or you could say it's the fixed initial charge they talked about in the question. So we could say that's the fixed initial charge, or you could say it's the cost, of going 0 kilometers. Part B says, give an interpretation of the gradient of the graph. So as the distance is increasing, the cost is increasing. So the gradient is how much the cost is increasing per how many kilometers you go. So you could say it's the cost per kilometer, or dollars per kilometer. So, and that's what we really need to say for those questions. Question 13 says f of x equals 4 over x minus 3 and g of x equals x minus 2 on x. Express the inverse function f to the minus 1 in the form f inverse x equals. So the way we approach these questions is we can say that let f of x equals y. That's going to make it easier to rearrange. So we can rewrite this equation as y equals 4 on x minus 3. Then we need to rearrange it to make x the subject of the formula. So we can multiply this side by x minus 3 and then divide by y. That's one way to do it. So we'd end up with x minus 3. Actually, let's take a couple more steps to do this. So x minus 3 times y equals 4. So we could expand these out, or you could just divide by y on this side. So x minus 3 equals 4 on y. And so x equals 4 on y plus 3. And now what we do is we change these values. So we say x is f inverse x and y is x. So we can say f inverse x is 4 on x plus 3. Or you could also, if you've done this working out slightly different, this will be the same as 3x plus 4 on x. They're the same thing. If you combine these fractions, you get 3x plus 4 on x. So either of those two answers is correct. If you check the mark scheme, they get something silly like 5 on 8. I really don't know where they pulled out 5 on 8 for the answer to this, but it's clearly wrong. So don't trust the mark scheme on this question. Part B says solve f of g of a equals 1. You must show your working. So let's firstly find an expression for g of a. So what will that be, g of a? Well, we take g of x is x minus 2 on x, and we replace the x's with a's. So this is going to be a minus 2 on a. All right, and so now we can say that f of g of a, we need to take this expression and put it into f of x, where the x is. So this is going to be 4 divided by all of this, a minus 2 on a minus 3. So all I've done is taken that expression I got for g of a and put it into where x is in this equation. Okay, so now we have an expression for f of g of a, and f of g of a also equals 1. So we can take all of this and make it equal to 1. So we can say that 4 divided by a minus 2 on a minus 3 equals 1. And now we have an equation with one unknown, so we're going to be able to solve for A using this equation. So let's go ahead and multiply all of this, everything on this bottom line over here. Anything multiplied by 1 is just itself. So we could say that x minus 2 on A minus 3 will equal 4. Then let's add that 3 to the other side. So A minus 2 on A equals 7. And now multiply by A. So A minus 2 equals 7A. And then take that A over to the other side. So we have to subtract by A. So we're going to get minus 2 equals 6A. And if minus 2 equals 6A, then A must equal minus 2 on 6. And that simplifies to 1 on 3. So minus 1 on 3. So A equals minus 1 on 3 for part B. Question 14, I have actually answered in another video, so check the description for the link to the answer or the walkthrough to this question. Question 15 says 60 apples are shared between Abby, Betty and Carol in the ratios 1 to 3 to x, where x is greater than 3. The number of apples in Carol's share is 18 more than the number of apples in Betty's share. Find the value of x. So we have the ratio, and typically in a ratio you multiply the numbers in the ratio by something to get the actual number of whatever you're talking about. So if we multiply 1 by something, we get Abby's number of apples. We multiply 3 by something, we get Betty's number of apples, and we add all of the numbers in the ratio up and we should get 60. So let's just say that 1 times something equals Abby's share. And 3 times something equals Betty's share. And we could say that x times something equals Carol's share. And in a ratio, these numbers are always the same. So let's just call that k. We could call it anything we like, I'm just going to use k. So 1 times k equals Abby's share of apples, etc. And we know that Carol's share is 18 more than Betty's share. So if we take Betty's share, which is 3 times k apples, and we add 18, we get Carol's share, which was x times that multiplier, which I've called k. So now I have an expression involving k and x, and I'm just going to leave that there for a moment. We can also say, because I know there's 60 apples, I can say that 1 times that multiplier plus 3 times the multiplier plus x times that multiplier equals 60. And I know that xk is the same as 3k plus 18. So I'm going to substitute this into this expression for xk. So I end up with 1k plus 3k plus 3k plus 18 equals 60. So then I can simplify this and solve for k, or the multiplier. So we could get 7k plus 18 equals 60. So 7k equals 42. So k equals 6. So what that's saying is, for every number in the ratio I can multiply it by 6 to get the number of apples that person gets. So the number of apples Carol gets will be x times 6, and it's 18 more than Betty's share, which will be 3 times 6, so Betty gets 18 apples, so therefore Carol must get 36 apples, so x in this case must equal 6. So that's one way of solving this problem. If you have a different method, let me know in the comments. I'd be interested to hear it. Question 16 says Ali has 2 solid cones made from the same type of metal. And here we have a diagram that says diagram is not accurately drawn, and the question goes on. The 2 solid cones are mathematically similar. The base of cone A is a circle with diameter 80 centimeters. The base of cone B is a circle with diameter 160 centimeters. Ali uses 80 milliliters of paint to paint cone A. Ali is going to paint cone B. Work out how much paint in milliliters he will need. So there's a rule about solids, at least about the solids we talk about in GCSEs, that are similar. If we have a linear measurement, we can find the linear scale factor between the two similar solids. And in this case, if the smaller cone has a diameter of 80 centimeters and the larger cone has a diameter of 160 centimeters, the linear scale factor there equals 2. So we've multiplied that by 2. And so because these are similar, as we've said, the surface area will increase. The surface area increases by that linear scale factor squared. So now we're talking about surface area, which is a two-dimensional area. So we square the linear scale factor. So we can say the surface area of cone B will be 2 squared, which equals 4. So it'll be 4 times the surface area of cone A. So we can say the surface area of cone B is 4 times the surface area of A, so we can say that we need 80 times 4, which is going to be 320 milliliters of paint for cone B. So we take the amount of paint we need for cone A, multiply that by 4, and we get the amount of paint we need for cone B. Then part B says the volume of cone A is 171,700 centimeters cubed. Work out the volume of cone B. Now there's a rule about the volume of similar solids, and it's you take the linear scale factor and you cube it. So the volume of cone B equals 2 cubed times the volume of cone A. Okay, so we just need to multiply, well 2 cubed is 8, so we need to multiply that number by 8. So get your calculator out, plug in 171,700, multiply that by 8, and we get 1,373,600. And that's your answer for part B. And that works with any solids. If you're talking about cylinders or cuboids or any of the solids we talk about in GCSEs, if you take the linear scale factor and you square it, you get the ratio of the surface areas. And if you cube the linear scale factor, you get the ratio of the volumes. Question 17 gives us a diagram, and it says AB is parallel to DC. DC is 2 lots of AB. M is the midpoint of BC. The vector AD equals 2B. The vector AB equals 4A. And part A says find the vector BM in terms of A and B. Give your answer in its simplest form. Okay, so let's put some labels on this diagram. So AD is 2B, going that way. And AB is 4A, going this way. We want the vector BM, which is in here. So we want to get from B to M. Because we know M is the midpoint of BC, we could find how to get from B to C and then half that, and that will give us BM. And we also have one more label we can draw on here because we're told DC is 2AB. So DC must be 8A. So one way to get from B to C is to go minus 4A plus 2B plus 8A. That will get us to C. Another way to do it is to go straight down from B to DC. And that's the vector 2B. And this, because I've drawn that line parallel to AD, this length in here must be 4A, must be the same as AB, and so this is going to be 4A in here. we can say that BC is going to be 2B plus 4A. So you can do that a couple of ways. Probably the easiest one to see is just to go from B to A to D to C. So we can say BC equals 2B plus 4A, and then BM must be half of that. So BM equals a half BC. So BM must equal B plus 2A. And that's your final answer for part A. Part B says N is the point such that DCN is a straight line and DC to CN equals 2 to 1. So here's N, so we're told that DCN is a straight line and the ratio of DC to CN is 2 to 1. So if this is 8A, this must be 4A, CN must be 4A. And part B says show that AMN is a straight line. Okay, so that's the line from A through M to N. And one way we can do this is to get the vector for AM and then the vector for MN. And if we can show that they're going in the same direction or that they're multiples of each other, then we can state that AMN is a straight line. So firstly, how can we get from A to M? Well, we can go from A to B and then B to M. Now we have the vector for B to M from part A, so we can say that AM is going to be 4A, which is A to B, and then BM is B plus 2A, so we can add that on. And then simplify this, so this is going to be 6A plus B. And also, can we find the vector for MN? Let's have a look. So we need to get from M to N, so MC, well that's going to be the same as BM. It's the same, the line has the same length, it's going in the same direction, so it must be the same vector. So the vector MC will equal B plus 2A as well. And from M to N, well that will be MC plus CN. So MN will equal MC plus Cn. So this is going to be B plus 2A plus 4A. So this is going to be 6A plus B. And what do you notice about Mn and Am? They're equal. So we can say Am equals Mn. And if two vectors are equal, that means they have the same direction and they have the same length. If they have the same direction, they must be on a straight line. So we can say therefore AMN is a straight line. Question 18 says, in the diagram DAPS and CBQR are straight lines. AB is parallel to QP and DC is parallel to RS. AD equals 11 centimeters, BC equals 5 centimeters, PS equals 27.5 centimeters, and RS equals 42.5 centimeters. Okay, so they've labeled all of those distances on the diagram already, and they've also labeled the parallel lines, and we're told that these two long lines here are straight lines. Okay, and part A says quadrilateral ABCD is similar to quadrilateral PQRS. So ABCD is this quadrilateral here, and PQRS is this one here. And it says work out the length of RQ, which is in here. Okay, so if these two quadrilaterals are similar, that means these lengths are increased by some scale factor. And on this quadrilateral, CB is the shorter side, and DA is the longer side. And in this quadrilateral, PS is the longer side, so QR must be the shorter side, because these lines are parallel. Okay, so we know that PS is similar to DA. So let's start off by saying that QR, the line we're looking for, enlarges CB, this shorter side, by some scale factor and let's just call that k. You could call it whatever you wanted. And that scale factor, well, that must be the ratio of PS and dA. So we can find that scale factor by dividing 27.5 by 11. 27.5 by 11, well, let's just whack that in a calculator. 27.5 divided by 11, and that gives us 2.5. So the scale factor of these two quadrilaterals is 2.5. So to find QR, we can multiply CB by 2.5. So QR is going to equal 5 times 2.5, and that is 12.5. So the answer there is 12.5 centimeters. Part B says work out the length of CD, and that's that line there. So we already have the scale factor, and that line is similar to RS. So we have the length of RS, and we can just divide that by the scale factor because this is clearly the larger shape. So we need to divide that number by the scale factor. So CD is going to equal 42.5 divided by 2.5. Put that into a calculator. 42.5 divided by 2.5, and we get 17. So CD equals 17 centimeters. Question 19 says the diagram shows a solid hemisphere. The hemisphere has a total surface area of 16 over 3 pi centimeters squared. The hemisphere has a volume of k pi centimeters cubed. Find the value of k. And they give us the formula for the surface area of a sphere and the volume of a sphere. But we're talking about a solid hemisphere. So what makes up this surface area of a solid hemisphere? Well, it's half of a sphere, half the surface area of a sphere, plus this circle on top. If this was a hollow hemisphere, then we wouldn't have to worry about this circle on top. But because it's solid, we have to work out the surface area of this half a sphere and then add this circle on the top of the shape. So by telling us what the total surface area of this shape equals, that will allow us to find what the radius of this sphere is, or this hemisphere. And once we have the radius, then we can work out what k equals. Okay, so we're given the total surface area, so let's take the surface area of a sphere, and we need to half that because we're talking about a hemisphere. So the surface area of a hemisphere will be half of this. Half of 4 pi r squared is 4 pi r squared divided by 2. So that's going to be 2 pi r squared. And we also need to add on this area of this circle on top of the shape. So we can say that the total surface area of this solid hemisphere will be 2 pi r squared, surface area of the hemisphere, plus the area of the circle on top, which will be pi r squared. And all of that equals 16 on 3 pi. Okay, so here we have 2 lots of pi r squared plus 1 lot of pi r squared, so that's going to be 3 pi r squared equals 16 on 3 pi. And we have a pi on both sides, so I can cancel those out. And multiply the left-hand side by 3 to get rid of this fraction here. So I'll get 9 r squared equals 16. So r squared equals, now divide this, the right-hand side by 9. It's going to be 16 over 9. And then square root both sides to get rid of this exponent. So r equals 4 on 3. The square root of 16 is 4, and the square root of 9 is 3. So now I have the radius of this sphere, which is 4 on 3. I can work out the volume. So the volume of a sphere is 4 on 3 pi r cubed. If I divide that by 2 to get half of it for a hemisphere, that will be 2 on 3 pi r cubed. So the volume is 2 on 3 pi r cubed. And we can we can now plug the radius in, which we found from this working out here, into this formula. So we'll get 2 on 3 pi and then 4 on 3 cubed. Then we get 2 over 3 multiplied by, now 4 cubed is 64, 3 cubed is 27, and that's all multiplied by pi. 2 times 64, that's 128. 3 times 27, that's 81 times pi. And now we have it in the form of something times pi. And in this case, we're looking for that value before pi. So they've told us to find the value of k, and they've said the volume is k pi, centimeters cubed. So we have it in the form of something pi, and in this case, k equals 128 on 81. So your answer there is 128 on 81. Question 20 says ABC is a triangle. AC equals 8.4 meters. Angle ACB equals 40 degrees. The area of the triangle equals 100 meters squared. Work out the length of AB. Give your answer correct to 3 significant figures. You must show all your working. Okay, so there's 2 steps we need to take here. And we need the sine rule for the area of a triangle and the cosine rule. So the reason they give us this area is to allow us to find CB. Let's call that X. Now the area of a triangle equals half AB sine C, where A and B stands for the sides, these 2 sides here, and C is the angle in between them. So they must be the sides adjacent to the angle. And so using this formula, we can use the area and side AC and the angle 40, and we can find this side CB. So if we say the area equals 100, and A, let's call A 8.4, and B is what we're looking for, so that's X times X, and sine C is sine of 40 degrees. Okay, so now what this allows us to do is to find the side CB. So we can rearrange this to get X by itself. So let's first do some working out. So this is going to be 100, half of 8.4 is 4.2, times sine 40 times X. And then, so therefore X is going to be 100 divided by all of this. So to get rid of this on the right hand side, I can divide it by the left hand side. So X is going to be 4.2 times 100 divided by 4.2 times sine of 40. So let's stick that into a calculator. So 100 divided by 4.2 times the sine of 40. And we get 37.041 approximately. Okay, so we have a length for CB now. And now we can use the cosine rule to find AB. Okay, so the cosine rule says A squared equals B squared plus C squared minus 2BC cosine A. In this case, this angle here will be angle A. This side will be the side A we're talking about. And B and C are these sides here. Okay, so we are looking for AB, so let's say AB squared equals B squared, which we've said was AC, so that's going to be 8.4 squared, plus C squared, which was this side, CB, so that's 37.041 squared. I'm just going to use my answer key in the calculator for that number to make it a little bit more accurate. And then minus 2 times B, which was 8.4, multiplied by 37.041, and then multiply all of that by the cosine of 40, which is the angle opposite the side AB. Okay, so now we have a formula for AB. We can go ahead and solve this, so put that into a calculator and then we'll be able to work out the length of AB. So let's write all of this down now. So we've got 8.4 squared plus the answer from the first problem. So I'm just going to put answer in my calculator, squared minus 2 times 8.4 multiplied by the answer again, and multiply that by the cosine of 40, and we get some number, 965, and we need to take the square root of that. So because this is AB squared, we need the square root of this number to get the final answer. So again, put the square root in, and then we can use the answer key again to save ourselves some work. Press equals, and we get 31.07889. Okay, so therefore AB equals 31.07889. And the question says give your answer correct to 3 significant figures. So these are the first 3 significant figures here, and we need to look at the next number, which is a 7. Is that 5 or more? Yes, it is, so we need to round that 0 up by 1. So our answer here is going to be approximately 31.1 meters. And that's the end of this paper. I hope you found that useful. Leave a like if you did. Leave a comment letting me know what you thought, or if you had any different methods to any of the questions. I really like to hear your working out if you had a different way of doing something. And also subscribe if you want to see more content. Once again, thanks for watching, and I'll see you in the next one. Bye for now.